Hi, today we're going to be talking about problems and solutions on energy analysis of thermodynamic cycle. The first question is state or define zeroth law of thermodynamics. And the second question is state or define thermodynamic cycle. Now, the answer to that is that the zeroth law of thermodynamics says that when two objects in the thermal equilibrium with a third object, they are in thermal equilibrium with one another. It simply means that if two bodies are individually in equilibrium with separate third body, then the first two bodies are also in thermal equilibrium with each other. So when talking about this zeroth law of thermodynamics, the zeroth law of thermodynamics is very similar to transitive properties of equality in mathematics. For example, if A is equal to B and B is equal to C, then A is equal to C. That's exactly the phenomenon of zeroth law. Now, the second question, the answer to the second question, which says define or state thermodynamic cycle. Thermodynamic cycle is a sequence of process that begins and ends at the same state.
Okay, the next question is state two major differences between a power cycle and a refrigeration cycle. And the answer to the question is a power cycle develops a work output, and that is W cycle equal to Q in minus Q out, while a refrigeration cycle receives a work input, and that is W cycle equal to Q out minus Q in. So there is the exact two differences between this power cycle and refrigeration cycle is that power cycle has its W cycle equal to Q in minus Q out, while the refrigeration cycle is W cycle equal to Q out minus Q in. So if you look at the power cycle, it starts with Q in minus Q out, while refrigeration cycle starts with Q out and ends in minus Q in. So that is the two common differences there. But they are not the same. And if you look at some examples, you know the one that has its power cycle and the one that is talking about refrigeration cycle. So if you see the one that is talking about power cycle, you know, because those ones we're talking about heat. And another difference is that a power cycle is characterized by its cycle efficiency, eta equal to W cycle over Q in, while a refrigeration cycle is characterized by its coefficient of performance, and that is beta equal to Q in over W cycle. Okay, the next question is, a refrigeration cycle operating in a system at steady state achieves a cooling effect of 17,500 kilowatts, while it loses 22,500 kilowatts of heat to its surroundings. Calculate the work input or output of this refrigerator in kilowatts and determine its coefficient of performance. So looking at this question here, we know that they're talking about refrigeration cycle and not power cycle. So refrigeration cycle is it receives work input. So the question here is calculate the work input or output of this refrigerator. So what we do here is to find the work input and not the work output, because the work input is refrigeration. You understand? So now what we have to do here is to find the work input, and that is the refrigeration cycle. The first thing we do is to use a formula, and that formula is the formula for refrigeration cycle, and that is W cycle equal to Q out minus Q in. So the Q out here is the amount of heat rejected or the amount of heat lost into the surrounding or lost into the surrounding. And the amount of heat that is lost to its surroundings in this question is 22,500 kilowatts. So the Q out is 22,500 kilowatts. And Q in is the amount of heat achieved. So the amount of heat received is 17,500 kilowatts. So Q out, which is 22,500 minus Q in, which is 17,500, will give us 5,000 kilowatts. So we are having our work input of this refrigerator as 5,000 kilowatts. Now the next question says that we should determine its coefficient of performance. So the formula for finding the coefficient of performance of the refrigeration cycle is beta equal to Q in over W cycle. So we use that formula because it is a refrigeration cycle. So what to do is beta equal to Q in over W cycle. Q in is the amount of heat transferred into the system, and that is 17,500 kilowatts. And W cycle is the work input of the refrigerator, and that is 5,000 kilowatts. And if you divide it, 17,500 kilowatts divided by 5,000 kilowatts is going to give us 3.5. So the coefficient of performance of this refrigerator is 3.5. And another question here is, a heat engine operating in a cycle develops work output of 150 kilowatts. And if you look at this, it says a heat engine operating in a cycle develops work output. And that means because of the heat engine and work output, it will be making use of the power cycle and the formula for the power cycle. So a heat engine operating in a cycle develops work output of 150 kilowatts and has a thermal efficiency rating of 30%. Determine for this engine the amount of heat transfer to the system and also the heat rejected by the system, each in kilowatts, when operating in a steady state. So what we've got to do first is to find the heat transferred into the system. So, and there is a formula you use to find the heat transferred into the system, and that is eta equal to W cycle over Q in. Like I said before, a power cycle is characterized by its cycle efficiency. So we use the formula of the power cycle, which is characterized by its cycle efficiency, and that is eta equal to W cycle over Q in. So what we do here is we find the subject formula for Q in, and Q in is equal to W cycle over eta. So we are making use of the thermal efficiency rating, which is of 30%. So in that eta, we change that 30% to eta by dividing by 100. So W cycle is 150 kilowatts. That is a work output, and that is the W cycle. You can also call it the net power or the power cycle. You can either call it the power cycle or the network output, or you can call it the work output of a particular engine. So the W cycle here is 150 kilowatts over 0.3, which is the cycle efficiency. So if we divide it, we get 500 kilowatts. So the heat transferred into the system is 500 kilowatts. Now, and that is it. And the next question in it says that we should find the amount of heat rejected by the system, and they all should be in kilowatts. So the amount of heat rejected by the system is the amount of heat transferred out of the system. And there is a formula which we need to use to find the power cycle, because we're talking about power cycle here, not refrigeration cycle, like I said before. So the formula for power cycle is W cycle equal to Q in minus Q out. So what we are using is the power cycle and not the refrigeration cycle. We're using the power cycle, even according to the question. in there, you will know that we are not talking about refrigeration. We're talking about power cycle. And the formula for the power cycle is Wcycle equal to Q in minus Q out. So they said that we should find the amount of heat rejected from the system. And the amount of heat rejected by the system, we find the subject formula for Q out, because Q out is the amount of heat transferred out of the system. So for the Q out, for the subject formula for Q out, we have Q out equal to Q in minus Wcycle. And Q in is 500 according to what we get, or maybe what we got. 500 minus Wcycle, which is 150. Remember that Wcycle is 150, and that is the work output of the system. So 500 minus 150 will give us 350 kilowatts. And 350 kilowatts is the heat rejected by the system. And that is it.